In this video, we will be taking a look at Unit 4, and we will be discussing inequalities and looking at lessons 1 through 6. No, coming in, we review this at the beginning of the unit, but students have learned that the less than symbol, and then that we also have a less than or equal to symbol, a greater than symbol, and greater than or equal to symbol. Now, when we're representing these on graphs, this is where we start to get into more of the middle school math. The inequalities they did in elementary school, but now we're taking it up a little and working with how we can graph these. And we have a couple like keys that we use to represent our less than and our less than or equal to, or greater than and greater than or equal to. If we have a number line and we're shading anything less than the target number, that means anything less than that number could be a solution, and we have an open circle, meaning that number would not be included. So let's just say this is the number 5. Then the solution would be any number less than 5, but not 5. Less than or equal to, we would use a closed circle, which would mean that it would include 5. So again, if I make this 5, then anything less than 5 and 5, including 5, could be the solution. And if we're doing greater than, using that same example, 5, anything greater than 5, not 5, but greater than or equal to, we would use the closed circle. That would be anything greater than 5, but also could include 5. The examples that I'm going to use in this part of the video are coming from the lessons 1 and 2 lesson summary. So if the students, and you scroll down to the bottom, you can see the lesson summary, and I'm going to go over the examples that are here in illustrative math. Okay, so when we're talking about inequalities, we refer to any value of the variable that makes the equation true. That would be the solution. So this is the example that was used in the curriculum, in the lesson, that the cost of movie tickets would be less than $10. So cost of movie tickets would be less than $10. So we would represent this as C for cost. So the C would represent the cost of the movies, and the total cost is going to be less than $10. So we would represent this on a graph by finding 10, and it would be an open circle because the price does not include 10. The cost is less than 10. The price of tickets, the cost of a movie ticket, is less than 10. So any number or any value less than 10. So students would shade in on the number line any value less than 10, and we would prove it, we would test it by picking any number on that number line to see if it was true. So we would say if C equals 3, is 3 less than 10? Yes, so we would say that is a solution. But if we said if C equals 12, is 12 less than 10? No, that is not a solution. And that is also being shown on the graph. 12 would be on this side of 10. So any number here would not be a solution for this equation, for this inequality. Now let's take a look at it slightly different. Suppose movie tickets were $10 or less. So in this case, we would say C is going to be less than or equal to 10. And in this situation, we would use a closed circle because 10 is a solution, but we would still shade in to the left because anything less than 10 would be a solution. And then we could test that out by just doing exactly what we did. If C equals 9, is 9 less than or equal to 10? Yes, it is. What if C is 10? Is 10 less than or equal to 10? Yes, it is. It's actually equal to 10. So 10 could be the solution. However, if C equals 15, 15 is not less than or equal to 10. Okay, so that would not work. Now sometimes writing an inequality can be a little more challenging. So suppose the students were given a scenario: you are allowed to get a driver's license when you are at least 16 years old. So you could be 16, you could be 17, you could be 18, etc. So we would say that in order to get your driver's license, you would have to be at least 16. So the value of X are unknown, whatever age it is. We could say X is the age of the person. They have to be either greater than or equal to 16 to get their driver's license. And then if we had to represent that on a graph, we would just sketch a number line. And we don't always have to label every specific number on the number line. We teach our students how to do sketches. So we know that the value of X, the age of any person, would have to be greater than or equal to 16. So I would put my 16, and I know that I'm going to be shading to the right greater than, because my age has to be greater than 16, but it could be 16 as well. In this case, we would use the closed circle. We would use a closed circle because 16 could be the solution. So if X is 16, 16 is greater than or equal to 16, and that would work. If X is 5, 5 is not greater than or equal to 16, that would not be a solution. Now, once we get into the lessons 7, 6, and 7, then we start solving inequalities. Now, solving an inequality is just like solving an equation. However, we're dealing with a range of numbers as our solution, not just one number. So the one example that they give in the summary of our math curriculum, suppose Elena has $5 and sells pens for $1.50 each. Her goal is to save $20. So if we were to write that as an equation, we know she has $5. That's her money she has, and she's going to sell pens at $1.50 each. So I might make P is equal to my pens, and she's selling each pen for $1.50, and her goal is to make $20. So if we had this equation, then students would solve, and they would say, well, if she's starting with $5, that means if I want to make 20, I'm going to have to make each pen worth a certain value that's going to get me to 15. So then I would do my math, and I would say that P would be equal to 10. So she's going to have to sell 10 pens at $1.50 in order to make $20. Now, how would that look if it were an inequality? What if she wanted to save more than $10? So students would set it up the same way. She has her $5, and she's going to sell pens at $1.50 each. And this time she wants to make more than. So this total has to be greater than 20. Whatever she has on this side of the equation has to be greater than 20. So we're trying to figure out, what does this number have to be that would create a value greater than 20. So we help students see it as an equation. They can still take the 5 away from both sides. So we know that she's going to have to sell at least 10 pens, right? At least 10 pens. But the question says that she needs to save more than 20. So our answer, instead of saying P would be equal to 10, we would say P would have to be greater than 10, because in order for her to make more than $20, the number of pens that we're going to sell has to exceed or be more than 10. If they think of what they learned in the previous units on solving basic equations, they're setting it up the same way, but when they are getting their answer, we're looking at this as an inequality. So she must sell more than 10 pens in order to make more than $20. So P would be greater than 10.